Hello guys, we are students from Uthm. Today we're gonna explain about the buckling of column. So to prove the buckling of column, we use three types of straw. Actually same type of straw but different diameters, from the small one to the medium one to the big one. So the modulus of elasticity of the three straws are the same. So the length is also the same. So the only one we change is the radius. So we are using both pin-sided supports. So let's see one by one.
Okay, I would like to explain about the buckling of straw 1. This is the model of our group, the first straw. And if you see, this is the smallest cross section. It's thin compared to the other two straws. Okay, let's see the buckling of this straw. Okay, let's see of the buckling of the straw when we use pin-to-pin support. Okay, as we see just now, when it's pin-to-pin support, the straw is actually can buckle easily. So now, based on the model, actually we already see that when it's having a thin surface area, it's easy to buckle, but let us prove it through calculation.
Now let's see the calculation for the straw one. So the elastic modulus equals to 4.76 gigapascal. The length L equals to 167 millimeter, and the radius of the straw is 2.5 millimeter. So the basic formula, the main formula is the critical load equals to pi square times E times I over length. So to get this I, there is another formula. So I equals to pi r power of 4 over 4. So we want to find the I first. So we substitute r equals to 2.5. Then we get this answer. Then we take this answer and insert into this formula. There go. Pi square equals to 4.76 times 10 power of 9 times 30.680 over 167 square. So the critical load equals to 5.00 times 10 power of 7 Newton. So when the critical load is low, the buckling of the straw occurs easily. That's it. Thank you.
As in straw 1, let's see the same concepts applied in this straw 2. Okay, now let's see the diameter of this straw. This diameter is even bigger than the straw 1's diameter. So it will affect the buckle of this straw. Let's see how it does it affect. When this buckle it, you see, it just bend a bit smaller than the straw 1. This is affected by the radius of this straw, and which changes through its to the critical load of this straw. Now let's see the calculation which proven that the straw is affected by the critical load of. Okay, now let's see how does the critical load affect the buckling of this straw through calculation.
Since the value of R for straw 2 is 3.5 millimeter, and the I of straw 2 is equal to 117.91. So the load of critical for straw 2 also change, equals to 1.99 times 10 power 8 Newton. Based on calculation of straw 2, the value for critical load of straw 2 is bigger than straw 1. So then we can conclude the buckling of straw 2 is more harder than straw 1.
Okay, now let's see the changes for the straw 3. As you can see, the straw has the biggest diameter. Okay, when we buckle this straw, as you see, there is no buckling occurs for the straw tree, and let's see for the calculation for the straw tree.
Okay, for the straw tree, we get it, the radius was 5.5 millimeter. So the value of I will be 718.688. So the last, for the critical of load, will be 1.21 times 10 of power of 9 Newton. So compared to the straw 1 and straw 2, thus the buckling for the straw 3 will be the hardest compared to the straw 1 and straw 2.
Okay guys, let us conclude within the 3 straws we use as our model. First of all, for straw 1, the critical load is 5.00 times 10 to the power of 7. And the second straw, the critical load is 1.99 times 10 to the power of 8 Newton. The third straw is 1.21 times 10 to the power of 9 Newton. So as we see here, the highest critical load is 1.21 times 10 to the power of 9 Newton, which is straw 3, and if you see that the radius is the highest. Thus, straw 3 is the hardest to buckle. Thank you.